Welcome to the Biochemistry Clinic. Today I want us to look at beta oxidation of unsaturated fatty acids. But please make sure you see the video on oxidation of saturated fatty acids for you to understand this easily. So the first aspect that I want us to look at is the oxidation of monounsaturated fatty acids, meaning fatty acids with only one double bond. And the example that we are using today is oleate, with 18 carbon atoms and only one double bond between carbon 9 and carbon 10. So here is the structure of our 18 carbon fatty acid with a cis double bond between carbon number 9 and carbon number 10. Now, what is the main difference between beta oxidation of saturated fatty acids and beta oxidation of unsaturated fatty acids? Well, the difference is here, the cis bond. So, the enzyme enoic-CoA hydratase, which catalyzes step 2 of beta oxidation of saturated fatty acids, can only work on trans double bonds and not cis double bonds. So this is the first challenge that we have. And that trans double bond should be between carbon 2 and carbon 3 of the fatty acid. Therefore, this demands that we bring in another enzyme that we never talked about in beta oxidation of saturated fatty acids, because we need help here. The enoic-CoA hydratase will not be able to work on the cis double bond. And that's where enoic-CoA isomerase comes in. What is the role of enoic-CoA isomerase? The role of this enzyme is to convert this cis bond into a trans double bond and ensure that it is in this position, carbon 2 and carbon 3 of the fatty acid, so that enoic-CoA hydratase can do its work. So when we quickly look at the structure, we have carbon 1 up to carbon number 18. So before we get to where the cis double bond is, we are going to have 3 cycles of beta oxidation that will occur without trouble. The only problem is when we encounter this challenge, the cis double bond. So before we get here, we have 3 cycles of beta oxidation, which are definitely going to get rid of 6 carbon atoms, 2, 4, 6. So the 3 cycles here indicated will get rid of 6 carbon atoms. That will leave us with carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had 18. We've removed these 6 carbon atoms. And now we have 12 carbon atoms. So tentatively, in your mind, make sure you see this as your new carbon number 3, because we have carbon 1, 2 joining here. So this becomes a carbon 3, 4, and so on. Now, after removing these carbon atoms without trouble, we face a cis double bond here. And that's why enoic-CoA isomerase comes in. So enoic-CoA isomerase is going to convert this cis double bond into a trans double bond. And because, remember, this is our new carbon 3 and carbon 4, this is not the correct position, 3 and 4. No, remember what we said. The correct position should be between carbon 2 and 3. So enoic-CoA isomerase will simply convert this to a trans double bond and shift it to the right position between carbon 2 and carbon 3. That is the role of our new enzyme that we did not talk about in saturated fatty acid oxidation. And then once that is done, the rest of the steps will occur, just as in beta oxidation of saturated fatty acids, starting with enoic-CoA hydratase, going to the dehydrogenase and the thiolase enzyme. And that will be it. Now, another interesting question is, what if we have more than one double bond? Now, here is an interesting structure of a fatty acid that has two double bonds. One double bond is between carbon 9 and carbon 10, and the other one between carbon 12 and 13. Linoleic acid, a polyunsaturated fatty acid, meaning that it has more than one double bond. So what is going to happen? Now, the first step is exactly what is happening with a monounsaturated fatty acid. Because we are dealing with these carbon atoms from carbon number 1 up to carbon number 9, we know we don't have issues here until we get to where the double bond is. So exactly what happened in the previous example is what will happen. We'll have 3 cycles of beta oxidation, which will simply get rid of this part. 6 carbon atoms. This part will be removed. So the difference between this structure and this structure is that this structure does not have the 6 carbon atoms. They have been removed via the 3 cycles, just like we saw in the other structure. This is just a condensed structure. So this leaves us with this structure. Now remember what we said? Once we encounter the cis double bond, this is the guy that we bring in, enoic-CoA isomerase. What is the role? Change this cis double bond into a trans double bond. And one other thing, if you are observant, what other thing should happen here, apart from changing the cis to the trans double bond? You will notice that this double bond exists between carbon 3 and 4. This is carbon 1, 2, 3, and 4. And what we said is that the trans double bond should be between carbon 2 and 3 instead. So enoic-CoA isomerase would definitely do justice. Convert the cis double bond. As you can see, this is cis because the hydrogen atoms are on the same side, and this is our new double bond, which is the trans double bond with the hydrogens on the opposite side. And then the double bond is between carbon 2 and 3. So this is carbon 1, 2, and 3. So this is in the right place. And in this position, we are rest assured that enoic-CoA hydratase can work on this. But then after doing this, you'll notice that we have these 4 carbon atoms before this cis double bond. So we can have at least 1 cycle of beta oxidation. So just watch the diagrams closely. What is the difference between this and this structure? You notice that only 1 cycle has occurred. So meaning we've just gotten rid of these 2 carbon atoms. So we're just giving 1 acetyl-CoA out at this point. Just 1 cycle of beta oxidation to leave us with this structure. So this is now a monounsaturated fatty acid because it has 1 more double bond. We've dealt with the first double bond, it's gone. Now we have to get rid of this double bond. But now, this is how we do it. Remember acyl-CoA dehydrogenase? This is the first enzyme in beta oxidation of saturated fatty acids. And what does it do? It simply creates a trans double bond between carbon 2 and carbon 3 of the fatty acid. And that's exactly what is going to happen here. So this is your new structure. A double bond, a trans double bond has been created between carbon 2 and carbon 3. Now, we have 2 double bonds that are just next to each other. What is going to happen? We will have another new enzyme, the second new enzyme that we didn't see in beta oxidation of saturated fatty acids. And this is a reductase. The first one was isomerase. This is the reductase. 2,4-dienoic-CoA reductase. What does it do? This enzyme utilizes the hydrogen atoms from NADPH, adds them to this structure. And remember your elementary chemistry, when you add hydrogen atoms to a double bond, the double bond disappears. So what this reductase does is that it gets rid of 1 of the double bonds here by simply adding 2 hydrogen atoms to this structure, courtesy of the reducing agent NADPH. And your new structure looks something like this. So we are almost there. Now we have our last or final trans double bond. But then there's only one thing which I want you to observe. There's only one thing that is not right with the trans double bond. So the only wrong thing is the position of this trans double bond. This is carbon 1, 2, 3, and 4. So it's between carbon 3 and 4. And this is not what we want for the action of enoic-CoA hydratase. So we bring in enoic-CoA isomerase, whose job is to simply isomerize this structure and make sure that the trans double bond is always between carbon 2 and 3, just like we see in this structure. So after the work of enoic-CoA isomerase, as shown here, enoic-CoA hydratase will rejoice because now this is a trans double bond and it's exactly between carbon 2 and carbon 3. So enoic-CoA hydratase can now bring in that water, and then we go through those normal steps that you know, the dehydrogenation reaction and the thiolase reaction, generating your acetyl-CoA. So basically, that is the difference between beta oxidation of saturated and beta oxidation of unsaturated fatty acid. Do not miss the next lecture.